Oh, good morning, class. Welcome. We're going to work on more Riemann sums. I mean, not really, but it just says that up there. Not really much more to do with Riemann sums. It might be like a question or two in here. Maybe it's like a word problem. Yeah, there's like a word problem on it. Let's talk about. Actually, I know how to make this bigger too. That's bigger. So we're going to do that. We're going to talk about what an integral is, notation, and all that. I did not talk about the notation of area. So right here is my, and I just went through the letter A. What a mistake that was. There's a letter A down there. So this is what area looks like in terms of notation for a formula. So it's like a big old S thing, and then like from A to B of a function dx. This is what an integral looks like. Okay, integral represents the area. So if y is a function is continuous and non-negative at an interval from a to b, then the area under the curve from a to b is given by this right here. This is called a definite integral. This region is always bounded by y equals x, the x-axis, in the vertical lines a and b, and is always it's not always positive. I'm gonna ignore that last part. It's not always positive. You can get negative area. It's totally possible. If it's below the x-axis, it will be negative. Now, if it's a Riemann sum, well, it says right here non-negative. Never mind. So if the function is non-negative, then yeah, of course the area will always be positive. Okay. So if it's non-negative, the area will be positive. So typically we do Riemann sums like with word problems. We don't get negative numbers because we're doing word problems like real world stuff. Okay. So let's set up an integral that yields the region bounded from y equals x plus 2, the x-axis, x equals 0, and x equals 3, and then we're going to solve it using geometry. Like I said last class, we're doing a lot of geometry in class now. So here is my axis. Okay. What do I need to graph on my axis? Probably my y equals x plus 2. Okay, so can we graph that? So how do I graph the line y equals x plus 2? Start at 2. And I go up how much and over how much? Up 1 over 1. So I'm going to start here. Up 1 over 1. So I'll just need like little tick marks. Actually, I'm not going to make... Yeah, I will. Yeah. So up 1 over 1, up 1 over 1, up 1 over 1. And when do I stop? 3. And why did I start at 0, by the way? It said from 0 to 3, so I'm going to do it from here to here. Bam. So I graph that from 0 to 3, and then I have to graph the lines y equals 3 and y equals x. Or sorry, x equals 3 and x equals 0, which is this right here. Okay? So it's really this lovely little red figure right here. I'm trying to find the area of this little red figure. Okay? Now, if I were to extend this as much as possible, like if I were to graph the line y equals x plus 2, it would look like that, and then this is the line x equals 3, and then this right here is the line of x equals 0. So you can kind of see how I can yield that red area between all of those curves. Okay? So without doing any calculus whatsoever, we're going to solve this integral. So let's first off set it up, and then we'll solve it by using geometry. So we're going to make our S. Okay? It's a really fancy S. Anybody know what S stands for? Very close. Sum. S stands for sum. Because the Riemann sum is when we add everything up. So it's a sum from A to B. So what's my lower bound? What's my lower x bound? 0. What's my upper x bound? What's my function? So that's how I write that down. That's the calculus speak. Now we could do this using calculus. I haven't taught you to do it yet using calculus. But let's do this using geometry. What shape is shaded in red? Okay, so trapezoid. So I find this by knowing the formula of a trapezoid. What is the formula of a trapezoid that we went over last class? So it's going to be base 1 plus base 2 over 2 times whatever the height is. So what is the first base? Well, I'm going to have to count a little bit, right? So this is a base right here, and this is a base right here. So what's the first base, which is, I'll just say to my left. How high is that? 2. Plus, how high is this next one over here? 5. All over 2. Times the height. Now in this case, my height's like sideways, so how high am I? 3. So I'm going to get an answer of 10.5. I'm going to call it 21 halves. Over float your boat. Congratulations. You just did your first integral. You're going to be telling your stories like this to your grandkids. I remember my first integral. It was on December 16th, approximately 9:15 in the morning. That's when I found my first integral. I remember when I found my first integral. It was the year 2006. It's about this time of year. I lived in Buffalo, New York, or thereabouts, and it was very cold outside. There was snow on the ground. It does not snow here, which is a good thing. I hate snow. Alright. So, I think I'm telling a story now, because I'm reading the rest of the notes now. However, a definite integral of a function can represent other fields, such as profit loss, water consumption, change of position, entrance, exit into a store. It can be a positive or negative value. Okay? So it can be a positive or negative value. So whenever we integrate this, okay, it's going to be the area that's above, and we're going to take away all the area that's below. I usually just label it as negative as I go through. That way I just add everything up. So I'm adding my positives and my negatives. So in the linear piecewise function to the right, which is right here, f has the given points and defined by negative 2 to x to 3. What's the value of negative 2 to 3, the integral of that, of f of x? So what I need to do here is I need to find the area of all of these lovely shapes. Okay? So I'm going to do some geometry here. I'm going to find the area of everything above. I'm going to label it. I'm going to find the area below. I'm going to label it. And then I'm going to add them up, and I'll be good here. So what looks like it's a little tricky here? What looks like it's a little off? All right, the one that's below, what makes it tricky? It's not just below the x-axis, but it doesn't clearly label this point right here. Can we use our brain a little bit here? Because it tells us what the slope of this line is. If we're going from 0,3 to 2, -1, what's the slope of this line? You can even count it. It's -2. So what do you think this coordinate point right here between 1 and 2 is? You don't. It's not even estimating. It's 1.5. It's not like, oh, it looks like it's in the middle. It's in the middle. No, you can use the idea of since the slope is 1/2. Every single block gets cut in half. Okay. So this is 1.5. So knowing that, let's find the area of. This is what I'll do. I'll do green. Green will be positive. Red will be negative. That was not Christmas on purpose, but this is really working out very well, especially since this kind of looks like a tree. No. I have to represent all of these celebrations this time of year, so whatever.
But I mean, if the tree's already up there, just finish the job there.
Maybe later. Okay, so how do you find the area of the quote-unquote green tree here? It's base times height divided by 2. Okay? So for the green, I'll do this in green. So my green triangle is 1/2 base times height. Well, what is the base? Just count. It's 3.5. So I'm going to get 1/2 of 3.5. What's the height? Let's do some math. What's 3 times 3.5? I'll worry about that 1/2 later. Final answer is 5.2, you said? 5.25?
Yeah.
Okay. So this is going to give me, what, that 1/2 is 0.5, and then this right here, 3.5 times 3 is 10.5. So cut 10.5 in half, and you're going to get... Some people are more comfortable with fractions. Those people are, we're okay with them. They might be a little weird to us, but that's okay. I'm actually a fraction person. As I was writing that down in decimals, like it was not feeling good through my body. I would do 1/2 times 7/2 times 3.
Okay.
I would have got 21/4.
Will you accept 5.2?
I accept either. Obviously, with multiple choice, you better know what the multiple choice is if you need to convert it. Well, I know, that's obvious. Well, not to everybody. Alright, now let's draw my trapezoid. What's my trapezoid area here going to be? It's going to be 1/2. What's the one base? This is of my red trapezoid. 1.5. I'm already scared. Plus, that should be a plus. Plus what? 1, that was terrible by me, times the height, which is 1. So I'm going to get 0.5 times 2.5. Yeah? Times 1, which is just 1. So what's 0.5 times? So it's going to be 1.25. But this is actually like a negative area, so I'll kind of label this up here. So this is... You're definitely going to see through my green tree here. 5.25. I can kind of see through that. And this is negative 1.25. Okay. So if I add those together, what do I get? You get 4. So negative 2 to the 3 of this function is equal to 4. Now you can tell your grandkids your second integral you've ever done. Oh, you'll be able to recall it. In 70 years? You're going to have grandkids in 70 years?
Like, they'll just be, like, existing by that time. I don't know if it's kind of like I'm 89, but I'm pretty sure, like, they'll be around when I'm 89.
I'm hoping they're more than around at 89. Alright, so we're going to take what we just did in terms of notation. I'm going to talk about Riemann sums again, but using that new notation that we now know, and kind of just putting it together, and then we'll get more into the integrals of geometry stuff. So all we did the first page was find the area using geometry. And that was it. Now let's go ahead and talk about a Riemann sum word problem right here, and let's go through it. Do I have a volunteer reader so it's not me talking the entire time? Who does not know how to read? You're exempt. Okay. So everybody else knows how to read. Want to read? Alright, cool. I got a volunteer. Quiet, everybody. Shh, quiet! You're all talking. You're annoying. Sorry. They're so rude. Oh, hold up. Why do you all keep talking? You're so rude. Like, you're rude when I do it, not somebody else, one of your peers. Stop talking. I can't believe we got to take retakes all the time. Continue.
Rocket A has positive velocity after being launched upwards from the ground. The velocity of the rocket is referred to as the net value between the integral of 0 and the height of the rocket is 140 feet.
Alright, so using this information, we're going to estimate the acceleration of the rocket at 45 seconds. So we're going to show our computations that led to that. So this right here is like an exact, this might have came off an AP, or maybe like a practice AP question, but it's got all parts A, B, C, and D. So let's go through this together here. I'll walk you through it as slow or as fast as I need to. We did a question like this last class. And we've done questions like this in the past before anyway. So how the heck do I find the acceleration at 45 seconds? Find the average rate of change. So let's set it up correctly. So to find the acceleration, it's going to be v of what? What two numbers should I pick out on here? 1540 to estimate 45. I like it. So 50 minus v of 40 all over 50 minus 40. Okay, actually this is going to be a little bit of an approximation here. Those little approximation guys on there. This gives you 1 whole point. That's a point. You can know nothing and get a point. I mean, I guess you had to know something for this, but you can do 0 like actual calculations and get a point. All right, let's go further now. So what is v of 50? It's 40 minus all over 50 minus 40. What's the top? What's the bottom? You can be done here. If you don't want to reduce, you don't have to. You can be done here. You can call it 1/2. I don't really care. This gives you another point right here. If you reduce it and write down 1/3, you don't get that point. So I suggest you don't reduce, because what if you reduce incorrectly and you're like, oh, 1/3? I've seen it happen to somebody in this room named Mason. I don't really know. So how do I get my final point, you think? It's like the last 4 words. Alright, indicate units of measure. So what are my units of measure? If this is feet per second, and I just did feet per second divided by second, it would be feet per second squared. Everything's in feet. Where do you see meters? I said meters? Yeah, no, they're saying I didn't say meters. Let's go back to the video. Alright, everybody, we just watched the video and I did not say it. I'm going with people that I trust other people. Okay, use a midpoint Riemann sum with 3 subintervals of equal length to approximate. Ooh, this is different for Riemann sums. This is very different. What does that mean? I'm just gonna stare at you until like somebody figures it out. What the heck does that mean? Like using a formula or whatnot. What can I do now with this? Like, because before it told me like, oh, you see 3 subintervals from this time to that time. No, it doesn't say that. It says this. So this is from what time to what time? 10 to 70. So I'm looking at right here. I'm looking at 10. I'm looking at 70. I need 3 subintervals. Okay. So 10 to 30. I like it. 32. I like it. And I like it. Why is that really nice? Because of the midpoint, I'm going to be using which numbers? 20, 40, 60. Let's do it up. Alright, so 10 to 70 of v of t dt equals, looks a little fuzzy, let me defuzzify it. Okay, so what's the first value? So what's the length of this first rectangle that I kind of half drew? It's 20 times the height, which is 22. Plus, what's the length of 20 times 35? Again, it's the width of the rectangle, and then this number down here gives you the height. So what's the width of my last rectangle? So they're all even. That's kind of nice. And then the height is 44. I'm going to say this was probably not a problem where we have a calculator. So let's just kind of do this one in our heads a little bit here. So we get 4,400 plus 700 plus 880. So 440 plus 700 plus 880. Is it seriously 2020? We should have taught this later. I didn't even write it right. 2020. I'm getting excited with my twos. Okay. So 2020. What's the units there? Just feet. It's going to kind of tie us into C. Let's explain the meaning of that. So why is it just feet? And this kind of really ties into C. Because what do we just do? Okay. What about the height? So we need to explain the meaning of this. What did we just find? The area underneath velocity. Yes. What does that mean? Okay. So it's distance. All right. So I'm really going to use a lot of the verbs from here. So it's the distance when rocket A was launched. So it's really the distance. Traveled. This one, unfortunately, you kind of need to write a little bit of an essay. So, Jonah, you better get this right. And if you don't, we're going to have a problem. Why is that ooh? It's not the first time I've said something to him. So this is traveled by rocket A from, you need to say, distance traveled by rocket A from what to what? 10 what? 10 seconds to 70 seconds was how much? 20 feet. That's it. So it's not like a real English sentence. Deal with it. I don't do English. I do broken English. Very, very broken English. So distance traveled by rocket A from 10 seconds to 70 seconds was... I guess I could put a the in front. It'd make more sense, but whatever. Okay, so that's how I explain it. So to explain something, you need to say the times. You need to say the times. Some people ignore that. They'll just say distance traveled by rocket A was 20 feet. Okay? You need to mention the times. You need to mention the verb of some sort. So in this case, it's going to be distance traveled, which is usually pretty typical. Okay? And you need to say what the distance was. And units matter here. Okay? So this is probably worth 2 points. I bet you the 2 points come from the verbs that you use with the timing, and then I bet you it's the units right here on 20 feet. Okay? And then the last part, what's the approximate height after traveling that 70 seconds? Think about that one real quick. Thank you. She's not here. I'll just email that person. Any ideas? I think I heard someone say it. What? What? 2150? 15? Where'd you get that? What did you add? I'm lost here. How did you get that? No one can see it then. Okay, so you did that. Okay. I'm looking for height. So this gives me the distance traveled. I just want the actual height, though. Someone has an idea? Mason just said draw a rectangle. Okay, 20. I heard now. That's correct. 2160. Why is it 2160? So it started at 140 at 10 seconds. So we're ignoring everything before 10 seconds. I think that's what Max is doing. Is he was including that. So just from 10 seconds, we know that's 140, and then from that, we can add the distance that it traveled. So this is going to be 140 plus my 2020, which gives me 2160 feet. Who said that? Oh, it wasn't loud enough. Be angry. I said that under my breath. Say it one more time. Yes. We're not assuming. We ignore physics. We ignore physics. Actually, the physics is already built into the problem. Alright. Okay. Let's do some properties of integrals, some like super basic properties. Okay. So this is assuming that for all of these, by the way, it's just assuming that A is less than or equal to B. Just as a heads up, we usually go from A to B. That kind of matters as we go through this, and you'll see why in just a second. So these are some just very basic properties. So the first one, we're integrating from A to A of f of x of dx. Any ideas what happens when you integrate from A to A? Why is it 0? There ain't no area. I like it. Because if you were to do like any type of estimation or anything, you get like a height of 0. So 0 times anything is 0. So this is going to give me a big ol' fat 0, no matter what the function is. The rest of them I might just need to tell you this. So this one, for number 2, goes B in the bottom, which is bigger, and then A on the top, which is smaller. You can always flip it if you negate it. These are just properties. These aren't like problems that you have to do. I'm just giving you properties. So you can always flip it if you negate it. That's a useful one. I use that one all the time. This one's just kind of obvious. So K is a constant. You can actually just pull the K right out. Same thing here. This one we can just add 2 different integrals. So we can go from A to B of f of x dx plus or minus integrate. So we're just integrating 2 separate things. I've never seen this one ever really used. Really. Pulling out of separate integrals. I say that and it'll probably pop up below. Let's go with this. For now we'll use this a little bit, but when you start to get comfortable with integrals, you'll stop doing that. Trust me. Next one, if you integrate from A to C and then from C to B, it's the same thing as just from integrating from A to B. This one's kind of weird. Alright, what if we're not integrating a function? Good try, but no. I'm integrating, so let's go to the last problem. Let's say that I don't have a function I'm integrating. I'm just integrating from 10 seconds to 70 seconds. Okay, how'd you do that? Which one? Oh, thank you. So it's B minus A. Alright, let's go through some of these problems. Now, I'm going to do 4 a little differently than what I think we want you to do, because I really want to emphasize this idea of using geometry. So I'm going to start with letters B and C before I do A. Now up here it gives us some information from what happening from 1 to 3. I'm going to kind of ignore that right now because I want to show you how you can figure this out yourself. Okay, you don't necessarily need these things right up here. So for the first one for B, we're integrating from 3 to 1 of 4x. Is there a property we can use to make this look a little bit nicer? You just said -4. I like it. Can I take that 4 out in front too while I'm at it? So -4. Since you made it negative, what happened? Okay. So now I know this says up here x dx is equal to 4. I want to show you why though. Isn't this just this line from here to here, from 1 to 3? Yeah. Okay. So isn't that just the trapezoid? What's the area of this trapezoid? Sure, just say 4 because it's up here. But you can easily, without giving this information up here, you can figure out that this is 4 right here. Okay, that's what I want to emphasize, is that we're going to start going through these. And to figure out integrals, you're going to need formulas. That's what it is. You're just using formulas. But if you know how to draw it out and you can skip the formula, do it. I advise it. Especially when we start getting to absolute values, because those are really going to stink. If you can draw it and you can count and do geometry, your life will be so much easier. So you're going to get -4 times, you said this is 4, so this answer is -16. Okay, so like a problem like this, again, I advise you, let's just draw it out. Nothing weird is going on here, so I'm just going to just draw from 1 to 3. So this looks something like this. So what's the value of this at 1, by the way? -2. So at 1, we're at -2. When does this cross? It's just set it equal to 0. 5/3. And then what's the value at 3? So this is, again, my lines. This is 1. And this is 3. Okay? Again, I just want to get you down with the idea what is that we can draw this stuff out and figure it out. Okay? Now, I'm actually going to go back and use the information I'm giving right up here. Why do you think I'm going to do that instead of counting out this drawing? Because that 5/3 is going to really bug me. Right? So, again, I want you to know how to draw this stuff out because it's going to be easier sometimes. You're just going to have to trust me on this. Alright? How can I use the formulas to break this one down? Oh, very good, class. We're just going to split it up from 1 to 3 of 3x dx minus 1 to 3 of 5dx. Didn't think about that? Maybe the drawing is easier then. Can't you just pull that 3 out in front here? So it's 3 of 3 to 1 of x dx minus, I'm going to pull that 5 out. So what is 1 to 3 of x dx? It says it right up here, so it's 4. So it's 3 times 4 minus 5 times, what's 1 to 3 of dx? Just 2. If you didn't know that, it's also given up here too. So what do we get? 2? 2. Very good, Mason. Hey, try A that we've been doing this. So A, this one we're not going to draw. Because we can't do geometry on x squared because it's got curves on it. It's got not straight curves. Try A using your properties and we'll come back in just a second together here. So try A using your properties. I'm going to call in a random person. Alright, who am I going to call on here? I'm not calling on you, Mason. Let's go with Jason. What'd you get? Do we agree? Oh, did we do a different A? You losers! It's okay. My bad. My bad. Oh, you got this as 3? I was going to say, that's not 3, but we'll talk about it. Oh, wow. My bad. This is all on me. All on me. My bad. I got a case of the Mondays. I'm Garfield. Love lasagna. Hey, we'll finish up 5, and then since we're talking about it already, then we'll go back to 4A. Oh, okay, let's go over 4A then, real quick. Equals 3 times 26 over 3? 26. Call everybody. Alright. So this one down here, we got 3 because we're just integrating from 0 to 6. It's just combining all those areas together. That was beautiful. No. Got something in my eye. What about B? 1. Why did we get 1? Negate it, so you just flip it. What about C? 0. I like it. AP does like to ask like at least one of these questions on every single exam. Like they like to ask a properties question. So that they would ask either A or B. They probably wouldn't ask C, but if they had C, it would probably be one of those questions like which of the following are true, and they would give you like 1, 2, and 3. I bet you like then this would be like one of the statements. You gotta figure out if it's true or not. And then D. We had 7? 17? That changed quickly. Yes, 17? 7?
Oh, no. Which one? 7.
7.
Yeah.
Let's do it. Come on! Pick the answer. Alright, ooh, actually I didn't do enough work here. I forgot my DX right here. That was kind of a fatal flaw. Okay, so let's go through it. So this simplifies to this. This is just, I just did algebra. You cool with algebra? Who said no? Is that you? I'm not talking to you. I'm talking to the person next to you. Yeah, you. You like algebra? Are you speaking on his behalf? Okay. So 3 to 6 is going to be -1, so I'm going to get 5 plus 12. Why is this one 12? Because you're a genius? Okay, good. She goes to Stanford. 6 minus 3 times 4. Beautiful. Okay, any questions on anything on the front page here? We're almost done. I see that clock going around 40. I hate when it gets that long, but it just is what it is. All right. Last one. I'm going to kind of put this one on you to practice a little bit. So we're going to come back to 6 because you can practice that one. I just want to real quickly talk about 7. We'll go back up to 6 because I want you to do 6 and then we can go over it. Let's look at 7. So it's a great question. Big fan of it. Big fan. Okay. The graph of the function is shown right here. Let's find g of 1, which means that we're going to plug in a 1 into this function right here. So we're going to be finding from 0 to 1 of f of t dt. So that's all we're doing is plugging in for that x value. Now let's solve this. What is it from 0 to 1? It's right here, from 0 to 1. It's a triangle. 1/2 base times height. It's 1. Don't be so angry over there. Am I going too fast? I mean, if I am, just let me know. What's the next one? Just plug it in, right? 0 to negative 2. That doesn't make sense. So what do I want to do to make sense of this? So from negative 2 to 0. That's not necessarily a trapezoid. What I would do is I would figure out how much I'm going from negative 2 to 1. How much is it from negative 2 to 1? It's 5. And then what about from negative 1 to the 0? So we got to do a little bit of work here. So this one would be a trapezoid, right? So I'm going to get negative. We said that first part was 5 plus the trapezoid is going to be 2 plus 5 over 2 times 1. Did I do geometry too fast? Okay, we're good. I think I lost where I got that 5 from. I'll make sure that we're all on the same page. Yeah, just counting it from negative 2 to 1. Because there's no that's not a trapezoid. There's like no formula for this shape from negative 2 to 0. So I just had to break it up. So what am I going to get here? 5 plus 7 halves. Don't forget that negative in front, which is so it's a negative 17 over 2. That made me very happy, which is the same thing as negative 8.5. Okay. Why don't you come up to, we're going to do 6. You're going to do it. I'm going to end the video, so if you're watching the video and want to find out the answers, go on Canvas. If you are not from Frisco and don't know what Canvas is, then email me directly with, I'll give you my PayPal information as well, with some money, and I will give you the answers. And that is all.